Hello everyone, welcome back to ThinkLab by Saurabh. So welcome to lecture 2 of our complete machine learning course. In the previous lecture we introduced machine learning, we understood what is the machine learning, we discussed what is the artificial intelligence, then we discussed the machine learning and deep learning. We also introduced our complete machine learning pipelining. So I want you to remember that pipeline: problem, data, clean, explore, feature, split, process, train, evaluate, tune, deploy, monitor, right? So today we are going to focus one of the most fundamental question in machine learning is the and that question is, what are the different types of machine learning? So by end of this lecture you should able to answer questions such as what is the supervised learning, what is the unsupervised learning, what is the semi-supervised learning, what is the reinforcement learning, what is the regressions, what is the classification, what is the clustering, and most important is when should we use each type. So let's begin. So if you see the bigger picture, so before learning the individual algorithms, so let's first understand the bigger pictures. So machine learning can be divided into the different learning paradigms. So the major four categories will be discussed here. So first one is the supervised learning, second one is the unsupervised learning, the third one is the semi-supervised learning, and the fourth one is the reinforcement learning, right? So you are able to see on the screen here. So first question is, what is the supervised learning? So the word supervised give us an important clue. Think about a teacher supervising a student. So the teacher provide the question and a student give the answer, right? And the teachers tell the student whether those answers are correct. So something similar happen in the supervised machine learning. We provide the algorithms with the example where the correct answer is already known and the correct answer is called as the label, right? And or we also call the target. Label and target both are the same thing. So in the supervised learning we have input data and the known output. That's the most important. The model learn the relationship between them, so we can represent, we can understand the supervised learning. We give the input features that know the target, machine learning algorithms, then they learn the pattern, then we train the model, and then finally new input, and then finally give the predictions. So let's understand with the example. Suppose we have about the different houses. So our features are house size, number of bedrooms, number of number of bathrooms, location, and the age of house. And our target is house price, right? So we already know the actual price of historical houses. So the model learned from those example after the training. So we provide the information about a new house and the model predict its price, right? So this is we call the supervised learning, right? So you can see here on the screen we have this in this slide. This is a supervised learning, and in the supervised learning we have a different classes, right? So you can see in the supervised learning we have a regressions and we have the classification. So we will go one by one. So the question is, first thing is the supervised learning has two major problem types. The first one is the regression and second one is the classification. So let's start with the regression. So regression is used when the target is numerical value. So usually we predicting a continuous quantity, for example house price, salary, temperature, revenue, sales, electricity consumption, delivery time. So take the house price again. Suppose our model going to predict 50 lakhs, another model going to predict 72 lakhs, another predict 1.2 cr. So these are the numerical values, and so this is the regression problem. So we cannot represent regression as features, machine learning model, and continuous numerical value, right? So this is the representation of the regression, features, machine learning model, and the continuous numerical value. And the keyword is, remember, to continuous numerical value will be used in the regressions. Now we are moving to some regression examples. Suppose our input features are size, bedrooms, age, our target is price. So we train the machine learning model using this example. Now imagine a new house. So the size is 1600 square feet and it has 3 bedroom, and it is 4 year old. So the model may predict 78 lakhs. So this is the regressions, right? Now we are going to understand what is the classification. So let's move to second major type of supervised learning, classification. So classification is a different from the regression. In classification we predict the categories, or we call the class. For example, the spam not spam, right? Fraud not fraud, disease not disease, positive negative, cat or dog. So here the output is not necessarily a continuous number. Instead of it represent the class. So you can visualize it here: input features, machine learning model, and finally the class category. So let's take an email example here. So we have a like history of emails. For each email we know whether it's a spam or it's a target. Could be a spam equal to 1 and the not a spam equal to 0. So the model learn pattern from this example, then give the model a new emails. So the model predict a spam or not a spam, right? So this is the classifications. So now we are moving to binary or multi-classifications, multi-class classification. So first is the binary classification. It means the binary means the two possible classes. For example, a spam, not a spam. This is the example of binary classes. Fraud, not fraud, right? So two classes mean the binary classification. Now let's consider the another example. Suppose we want to classify an image as a cat, dog, horse and bird. So now we have more than two classes. So this is called a multi-class classifications. We can also have a multi-label classification. So one example can belong to multiple category at the same time. For example, imagine an image containing the car, person, dog. So the model may assign the multiple labels at the same image. So binary classifications for the remembering part. Binary classifications, two classes. For the multi classification we have one classes from the multiple classes. Multi-label classification, it means multiple label can be assigned. So now we are going to understand the unsupervised machine learning. So you can see here on this particular slide, you are able to see unsupervised machine learning. So let's move to second major learning parts, unsupervised learning. So this is a different from the supervised learning. In supervised learning we have labels. In the unsupervised machine learning we don't have predefined labels, right? So you can see here in the unsupervised machine learning we don't have a predefined labels. So we simply have a data, and we ask the algorithm, can you discover the interesting pattern or cluster or some structure in this data? So let's understand with this example. Imagine an e-commerce company has a 1 million customer. So the company has informed about the customer spending, purchase frequency, average order value, product categories, website activity, but there is no label saying. So this means a premium customer, or this is a budget of customer. So this company want to discover the customer segment. So this is where unsupervised learning can help. So the clustering algorithm may discover the group automatically, right? So if you see the like pipeline, so first we take the customer data, then we use the clustering algorithm and we divide into different groups. So these algorithms discover the group from the data, and we didn't provide the answer beforehand. So this is unsupervised learning. So now we are moving to one of the most important unsupervised learning is the clustering, right? So we first try to understand what is the clustering here. So we can see on the screen we are defining the clustering. So clustering means the grouping the similar data point together. So let's imagine we have a customer. Suppose the customer spend very little. Some spend a moderate, some spend a lot. So the clustering algorithm may automatically create a groups. For example, cluster 1 low spending customer, cluster 2 medium spending cluster, cluster 3 high spending cluster. So this algorithm does not necessarily know these names, so it simply identify the group based on the similarity. So we as a human interpret the group afterward, and one of the most famous the clustering algorithm is k-mean, where we will study k-mean in detail later in the course. So we will also studying the hierarchical clustering and the DBSK. Now we are moving to dimension reductions. So after the, another important unsupervised learning concept is the dimension reduction. So what does dimension reduction means? So it's simple refer to the number of features or variable. This is called the dimensionality, right? So imagine the data set contain 500 features. So working with the 500 features can be difficult. So some feature may be, some different, some may contain the different useful information, and the visualization become difficult. So we may want to represent the data using the fewer dimension while representing, as a much useful information as possible. So one of the famous technique is PCA. So principal component analysis. So we will study PCA later. For now, just remember clustering finds the groups and dimension reduction represent the data using the fewer dimensions. Now we are moving to semi-supervised learning. So this approach combines the idea of the supervised and unsupervised learning. So imagine that we have 10,000 images, but only 500 images are labeled and rest remaining images are unlabeled, right? So if you are able to see here, this is the as we are talking about the semi-supervised. So, a small amount are labeled data with a large amount of unlabeled data, right? So this is the semi-supervised. So that is the basic idea behind the semi-supervised learning. So this data contain labeled data and also unlabeled data, and then we perform the semi-supervised. So this approach can be useful when the labels are expensive but raw data is is important. So now we are talking about the reinforcement learning, right? So you can see on the screen we are going to display this reinforcement learning. So let's move to another most important learning, right? So this is we use the reinforcement learning. So reinforcement learning work differently from the supervised learning. So there is an agent and there is an environment. Agent takes an action, environment respond, and agent will receive the rewards or penalty over the time. So agent learn which action lead to better rewards. And let's imagine a game. So agent is playing a game. It chooses an action. So maybe moves left, maybe moves right, maybe it jumps. So the game environment respond. If the action is good, the agent receive a reward. If the action is bad, the agent may receive a penalty over the many interactions. So the agent learn from this strategy. So in the screen you can see this is the loop here. First is the environment, observe, agent, action, environment. Then we talk about the rewards and penalty, and finally we return to agent. So this is the thing. This is the fundamental idea behind the reinforcement learning. So there are lots of application of reinforcement learning. First one is the game playing, robotics, autonomous decision making, resource optimizations, and the many other areas. So we'll not go deeply into the reinforcement learning in this course because it's a large topic by itself. So our primary focus on the classical machine learning. So now we are talking about the supervised versus unsupervised, right? So this is a very extremely important. So supervised learning, the data plus labor and learning algorithms, then we go to model, and finally it will going to predict. So this you can see here inside this part, if you are able to see here, in the supervised learning we provide the data plus labor, then we move to learning algorithm, and then the move to the model and going to predict. Unsupervised machine learning, data without label, learning algorithm, and discover the pattern, and finally it will going to divide into the groups. So the biggest difference is in the supervised learning we have a targets label. In the unsupervised learning we don't have a predefined target label. So now we are talking about the real world example. So I will give you some problems, and you tell yourself what type of machine learning is this. Example 1. Predict the price of a house. So what is it? So this is regression because we are going to predict a numerical value. Example 2. Predict whether the customer will leave a company. What it is? It's a classification or regression. The answer is classification because the output could be 0 or 1, like either stay in the company or leave the company. Now we are talking about the example 3. Group customer based on the purchasing behavior. What it is? Clustering or like classifications or like regression? So answer is clustering, because we are going to discover the groups without predicting the label, right? Next example is the reduce 100 feature into the 10 important component. What it is? Regression, clustering, classification, or dimensional reduction? So answer is the dimensional reduction, and one technique we can use in the PCA. So next we are moving to the next example. Train a Zen to play a game and using the rewards. What it is? Reinforcement learning or clustering and the classification? So the answer is the reinforcement learning. So the question is, how do we choose the type? So now come to the most important practical question. How do we decide which type of machine learning to use? So start with the problem. Ask yourself, do I have a target or label? If yes, you probably dealing with the supervised learning. Then you ask if the target is numerical. If yes, so it may be the regression. If the target represent a category, it may be the classifications. If you don't have a label, you may be dealing with the unsupervised learning. Then you ask, are we trying to discover group? If yes, so think about the clustering. And next is, are we trying to reduce the number of feature? Then think about the dimensional reduction. If the agent is learning through the action in reverse, so think about the reinforcement learning. So this our decision will be, if you see the flow diagram, we start with we can ask the question, do we have a label? If yes, so we will move to supervised learning. If no, that will be unsupervised learning. In the supervised learning, there is a numerical target, so it means the regression. If there is a categorical target, then we have to classification, right? So now we are going to connect with the our ML pipeline. So let's connect today's lecture with the pipeline we learned in the lecture 1. So remember our pipeline: problem, data, clean, explore, feature, split, pre-process, train, evaluate, tune, deploy, monitor. So type of machine learning problem is identified very earlier, usually during the problem definition. For example, if our business is predict a house price, so we identify the regression. If the problem is detect the fraud detection, so we can consider as a classification. If our problem is group of customers, so we will identify as the clustering, right? So the choosing the machine learning is directly to our first step is the problem definitions, right? Okay, so now the most important takeaway from this today video is, so let's summarize today's lecture. So there are four major learning types. First one is the supervised learning, second one is the unsupervised, third one is the semi-supervised learning, and the fourth one is the reinforcement learning. Supervised learning use the label data. Unsupervised learning includes regression and classification. Regression predict the numerical value, classification predict the categories. Unsupervised learning work with the predefined label, and the important unsupervised tasks include the clustering and the dimensional reduction. Semi-supervised learning combines the label or unlabeled data. Reinforcement learning involves the agent, environment, action, rewards, right? So the one thing I want you to remember, if you remember only one thing from this lecture, so you know that will be the fruitful. So remember this decision, machine learning, do you have label data? If yes, so that will be the supervised, we know. Then unsupervised, if the for then after that we have to use for the regression, classification, finally clustering and PCA. So this thing we have to remember, right? So now we are going to, today we learn the different types of machine learning. So I started with the supervised learning, then we learned the regressions, then we learned the classification, and then we discussed the unsupervised learning, then we learned the clustering, dimensional reduction, then we briefly introduced the semi-supervised learning, and finally we understood the reinforcement learning. So we will also connect all this type of our machine learning pipeline in the next lecture. So we are going to take another very important step is, we have learned the complete machine learning workflow. We will take the real machine learning problem and go through the workflow step by step. We will understand how to define the problem. We will understand how to collect the data, how to inspect the data set, how to clean the data, how to perform the EDA, how to prepare the features, how to split the data, and how to prepare the everything before training our first model. So don't skip the lectures, because from the next lecture we are going to start becoming the much more practical. If you are following this complete course, so make sure you subscribe the ThinkLab by Saurabh and follow the complete playlist from lecture 1 to lecture 35. So thank you for watching. Keep learning, keep building, keep becoming 1% better every day. So I will see you in the next video lecture 3. So thank you for watching. Happy learning.